All right, so doing a lot of measurements, learned how to read instruments. Now we have to talk about the digits of the measurement. We're going to talk about something called significant figures. This is a potentially difficult concept in chemistry. It's new. It deals with math. It's not that the math is hard. It's just that this is a weird way of looking at numbers, and it's going to be unusual for you, and that's okay. But it's how we do things in science. In science, most of the numbers that we use are measurements, and we already know that measurements are uncertain. There's that last digit, the one that you estimate. Well, that uncertain digit is important, but it affects what we do with the numbers. So to start with, the definition of significant figures. All of the digits in a measurement that are certain, in other words, you know because there are lines, plus that one last digit, the uncertain digit. All of those are significant figures. There are rules. Now, these are nice in that you don't actually have to understand why the rules are the way they are. You just have to be able to apply them. You have to learn the rules and apply them. So there are 6 rules. We're going to look at the first 5 because the first 5 deal with almost every measurement we're going to be working with. The 6th one is for rare cases, and we'll talk about that in a second. So the first rule of significant figures is easy. Anything that's not a 0. All non-zero digits in a measurement are significant. They're important. They're part of the measurement. Easy enough. Rule number 2. If you have a 0 that comes between non-zero digits, any number of zeros that are in between non-zero digits, those are significant as well. They're part of the measurement. So now we have to get into what happens if the zeros aren't in between non-zero digits. What if they're at the end or at the beginning of the number? What do we do about them? So here are the rules. If you have a 0 in front of a number, it's the first part of the number is a 0. It's leading zeros. They're never significant. They do nothing but hold the place of the decimal point. And if all they're doing is holding the place of the decimal point, they're not part of the measurement. They're part of how you tell how big the measurement is. If they're at the end of the number, then it depends on where they are in relation to the decimal point. So if they're at the end of the number and after the decimal point, to the right, then they're always significant because they speak to the accuracy of the instrument that you're using. If they're at the end of the number but they're before the decimal point, the left of the decimal point, then they're not significant. Now there is a little star by this rule because there are some exceptions to this one that we might encounter, and we'll talk about those as they come up. Okay? So let's do some examples of counting the number of significant figures. All right? Here are some examples of some measurements that we've taken in lab. There are several of them. They're all different kinds of measurements, but they're all measurements. They all have a unit with them, which makes them measurements, and we know that there's some uncertainty there. What I want you to do is stop the video and take a few minutes, jot down each of these numbers, and count, just count, according to the rules we've just learned, how many significant figures there are in each of these measurements. Stop the video and tell me how many in each of these measurements, how many sig figs are there. I'll wait. I said stop the video. Are you ready? All right, so let's take a look at what you've got as your answers, and we'll see if they're right or not. So A, 1.254 grams. Rule number 1 says all non-zero digits are significant, so that means that there should be 4. All 4 of those sig figs, all four of those digits are significant. What about the next one? 2.0075. Well, I know according to rule 1 that the 2, the 7, and the 5, they're significant. But what about the zeros? Well, where are they? They're between non-zero digits, so they're also significant. That means that there are 5 in that number. What about C? 3.45000 millimeters. Well, we know the 3, the 4, the 5, those are all significant because rule 1 says any non-zero digit is significant. What about those zeros, though, after? They're not in between non-zero digits, so I can't use rule 2. Where are they? Well, they're at the end of the number. Where are they in relation to the decimal point? They're after the decimal point. They're at the end of the number and to the right of the decimal point. According to rule 4, they are always significant. So all 6 of those digits are sig figs. Sig figs is how we abbreviate significant figures. Let's look at the next one. 0.0002320 liters. All right, well, I know the 2, the 3, and the 2, those are significant. What about the zeros in front? Well, Rule 3 says zeros in front of a number are never significant, so they don't count. So I can just ignore those. They're just placeholders. The 2, the 3, and the 2 are. What about the 0 at the end of that number? Is that significant or not? Well, it's at the end of the number, and it is to the right of the decimal point, so it must be significant. So that means that that measurement has 4. What about the next one? E, 47,000 milligrams. Well, I know the 4 and the 7 are significant, but what about those zeros? Where are they? They're at the end of the number. Which side of the decimal point? Well, they're on the left of the decimal point. So according to that last rule, Rule 5, those shouldn't be significant, and that means that only the 4 and the 7 are. And finally, we have this weird number, 6.02 times 10 to the 23rd atoms. That's a very important number in chemistry. It's called Avogadro's number. We're going to look at that one much more closely later on. But how many significant figures does it have? Well, this is a number in scientific notation. And when we have a number in scientific notation, we can ignore the exponent, the power of 10. That's not part of it, because all that is a placeholder. So really all I need to worry about is the 6.02. The 6 and the 2 are definitely significant because of Rule 1, and that 0 in between them is also significant, so this has 3. How'd you do? Did you get them all? If not, we're going to be working on this. You can definitely ask questions in class. Now, Rule 6, I told you there were 6 rules. Rule 6 only occurs at certain times, and one of the times that we see Rule 6 is that when we count anything, for example, if we were to count up crackers, right? If we count them, we are assuming that our count, we count items, that's infinitely certain. And so there's no uncertainty when we count, unless you can't count. If you can't count, you maybe shouldn't be in this class. But assuming you can count, when you count something, you're 100% certain or 0% uncertain. And since you're very, very certain, we consider the counting numbers to have an infinite number of significant figures.